The interplay of theory and observation or experiment is basics to the progress of science. Science is ever dynamic. There is no final theory in science and no unquestioned authority among scientists. As observation improved in detail and precision of experiment yield new result, theorists must account for them if necessary by introducing modification. Sometimes the modification may not be drastic and may lie within the framework of existing theory. For example, when Johannes Kepler examined the extensive data on planetary motion controlled or collected by Tycho Brahe, the planetary motion orbits in heliocentric theory, that is, sun at the center of the solar system, imagined by Nicolaus Copernicus, had to be replaced by elliptical orbit to fit the data better. Occasionally, however, the existing theory is simply unable to explain new observation. This causes a major upheaval in science. In the beginning of the 20th century, it was realized that Newtonian mechanics, till then a very successful theory, could not explain some of the basic features of atomic phenomena. Similarly, the then accepted wave picture of light failed to explain the photoelectric effect properly. This led to the development of a radically new theory, that is the quantum mechanics, to deal with atomic and molecular phenomena. Just as a new experiment may suggest an alternative theoretical model, theoretical advance may suggest what to look for in some experiment. The result of experiment of scattering of alpha particles by gold foil in 1911 by Ernest Rutherford established the nuclear model of the atom, which then became the basic of the quantum theory of hydrogen atom given in 1913 by Niels Bohr. On the other hand, the concept of antiparticle was the first introduced theoretically by Paul Dirac in 1930 and confirmed 2 years later by the experimental discovery of the positron or anti-electron by Carl Anderson. Physics is the basic discipline in the category of natural science, which also includes other disciplines like chemistry and biology. The word physics comes from the Greek word meaning nature. In Sanskrit, equivalent is bhatiki, that is used to refer to the study of physical world. A precise definition of the discipline is neither possible nor necessary. We broadly describe physics as a study of the basic law of nature and their manifestation in different natural phenomena. The scope of physics is described briefly in the next section. Here we remark to the two principal thrusts in physics, that is, unification and reduction. In physics, we attempt to explain diverse physical phenomena in terms of few concepts in law. The effort is to see the physical world and manifestation of some universal law in different domain and condition. For example, the same law of gravitation given by Newton describes the fall of an apple to the ground, the motion of the moon around this earth, and the motion of the planets around the sun. Similarly, the basic law of electromagnetism, Maxwell's equation, govern all electric and magnetic phenomena. The attempt to unify fundamental forces of nature reflects the same quest for unification. A related effort is to derive the properties of bigger, more complex system from the properties and interaction of its constituent simpler parts. This approach is called reductionism and is the heart of the physics. For example, the subject of thermodynamics, developed in the 19th century, deals with bulk system in terms of macroscopic quantities such as temperature, internal temperature or internal energy, entropy, etc. Subsequently, the subject of kinetic theory and statistical mechanics interpreted these quantities in terms of these properties of molecular constituents of the bulk system. In particular, the temperature was seen to be related to the average kinetic theory or kinetic energy of the molecules of the system. Thank you.